So we're going to be dealing with what, no, it's fine, come on in. We're going to be dealing with what is known as trigonometry, or the kind of mental default is sine, cosine, and tangent. We're going to be talking a little bit about what it means and how to use it, but the thing that he asks that I have you check first is that sometimes you will be asked to calculate things in the calculator. Frequently they do it without the calculator, but sometimes they do need the calculator. And so he wants you to make sure that you are checking your mode. There should be a mode button on your calculator, and like the second or third option down, how far is it? Third or fourth. So they want you to be in degree. Its default says radians, which is something that you'll learn more about in Algebra 2 and afterwards. But you want your mode to be in degrees. Is anybody having trouble finding that? It's essentially a unit of measurement. It's like the difference between doing math in feet or math in meters. You are still finding a correct answer, but your answer will look very, very different. So that's why we have that.
Once you get to here or whatever.
So once you're here, you need to arrow over and hit enter, and now it's selected, and you're good. Anyone else? Okay, we just want you set up for success. Especially for this class in general, you are not dealing with radians yet, so you can just leave it in degrees. If you have a class that is dealing with radians, hopefully you've gotten pretty good at switching back and forth, depending on what you need. All right, so the first start has nothing to do with the calculator and nothing to do with even trig ratios yet, but it's a little bit of useful background information. When we talked about geometry, did I talk about Pythagorean triples? Pythagorean triples are whole numbers or nice, pretty, even numbers that work for the Pythagorean theorem. And the test likes them because it's not particularly interested in the answer, it's interested in the process. So the most famous one is 3, 4, and 5. What happens is if we take 3 squared plus 4 squared, it will equal 5 squared. 9 plus 4 squared, 16, is equal to 5 squared, which is 25. And so these three numbers show up a lot when they're talking about right triangles, just because they're easy defaults. I guarantee that there will be a 3, 4, 5 somewhere on your test. It always shows up at least once. Other ones that do show up but aren't as memorable is 5, 12, and 13. 5 squared plus 12 squared is equal to 13 squared. And there's 9, 41, and 42. 9 squared plus 41 squared equals 42 squared. Again, this is the one that I can about guarantee will show up. The others, maybe. But those Pythagorean triples are things that work for these perfect, all even numbers. If I pick numbers at random, for instance, 4 squared and 7 squared, this is going to end up being a root of something or a long decimal, depending on how you answer it. But it's not these nice, pretty numbers. So, quick review of Pythagorean theorem. How do you solve this one? What would you do?
You just take like the squares of both of them,
Yeah.
and then take the square root of it.
Yes. You'd say 4 squared is 16, 7 squared is 49. Calculators are okay. 16 plus 49, 65. So we get 65 is equal to c squared. We take the root of both of them to cancel the square. Square root cancels to just c square root of 65. Whatever that is, it's not a nice, pretty whole number. Frequently, it will have you leave it in this form. Sometimes it'll ask you for the decimal approximation. If they ask for the decimal approximation, they tell you what place to round to, because it's not possible to get the real answer. Your calculator's going to cut it off at some point. They'll say round to the nearest whole number or the nearest tenth or the nearest hundredth, they tell you. So, with that, the idea of similar triangles is triangles that are the same size. Well, not same size, same shape. They can be different sizes, but they're the same shape. I make the connection of when you get pictures printed or you have a picture on your screen, if you keep it proportional or you keep it similar, then the picture looks right. It doesn't matter if it's this big or this big. If it gets distorted, it's because things are out of proportion. They're no longer similar. Maybe you're 3 times as tall, but only twice as wide. And suddenly your looks tall and skinny stretched like a funhouse mirror. So similar keeps the proportions. And so rather than 3, 4, 5, we can double each of these and get 6, 8, and 10 will also be a triple. It will also work with the Pythagorean theorem being a perfect, nice number. With this idea of similarity is where these trig ratios come from. If we have this triangle, where this side is 6 inches, meters, 6 units long, and this side is 8 units long, and this side is 10 units long, the trig ratios are making comparisons among these sides. And so if I have this smaller triangle with 3, 4, and 5, if I compare the bottom to the long side, I would be saying 8 over 10. What does that fraction reduce to? 4 over 5. They're both even. They're both divisible by 2. It equals 4 over 5, which is the same as the bottom to the hypotenuse, or 4 over 5. And so when you have these similar triangles or these same shaped triangles, it's always the same comparison, even though they get to be different sizes. And so I don't know exactly when it started, but I know that it was very well known by the 40s, 50s, 60s. They started keeping track of all of the ratios, not just 4/5. They came up with the ratios for every single angle they could think of. And not just the whole angles, but the tenths of angles, the hundredths of angles. And they would list all of them in a big fat book. We no longer have to use the big fat book. One of the beautiful things about your calculators is that it stores all of them. And so what happens with your calculator is you are going to be saying, I want the sine of 37.8. If you type that into your calculator is going into that giant database and looking up what kind of fraction uses and gets that particular, is associated with that particular angle. Every single angle has its own fraction ratio, but it's stored as a decimal and it's stored in your calculator, in your computer. And so when you type this, it's not an operation. It's not like add, subtract. It's literally just saying, go find it in the list. So that's what's going on with those. That's the background information. In order to be able to use our trig ratios, we need to be really super confident about what the pieces are called. So, eventually, it can be used on something other than right triangles, but for the purposes of starting out and for the purposes of the ACT test, it's always going to be with right triangles. So, we're starting with our right triangle. Which one is the hypotenuse? The slanty one, the one that is the longest, the one that is across from the right angle. The hypotenuse is always the hypotenuse. If you've ever seen Sandra Boynton's picture, she has one where there's a little hippo laying along this line, and it's called the hypotenuse. But anything you can do to remember the long side is always the hypotenuse, and back to our Pythagorean theorem, it's always the C of the Pythagorean theorem. The other two sides that we have are opposite and adjacent. So, I am standing opposite you. The person who is sharing the table with you is adjacent to you. Opposite is going to be straight across from something, whereas adjacent is the one right next to, the one that is right by your elbow. So, when we speak of opposite and adjacent, it needs a point of reference. You are opposite me, but if I walk out of the room, you're no longer there. And so you have to have something to compare it to. You can't just be, oh, I'm opposite. Well, opposite what? So, if we talk about this angle right here, I'm going to call it A. Which side is opposite? Yeah, this one over here. Frequently, it's labeled as little a, is how it's labeled as opposite, but this is opposite A. If that one is opposite A, which one is adjacent to A? So technically both of these are adjacent, but hypotenuse is already taken. That one's always the first one. It's labeled by default. Adjacent is a shorthand for adjacent leg. And a leg is going to be these shorter pieces of a right triangle. So this is adjacent. So if this is our angle A, up here I'm going to put angle B. What is opposite B? Yeah, the flat one. Good. Which makes this the adjacent to B. Also, remember opposite B is frequently written as lowercase b. And that would make our final corner C, just for the sake of filling in our drawing. So whether it's opposite or adjacent, you have to go back to the angle that you're speaking about. You have to have a point of reference. This side is both adjacent to A but opposite B. It depends on which angle, whether it's an opposite or an adjacent. I'm gonna double check that I don't have anybody waiting in the room. Good, we're good. So that is our point of reference. Now we get our three tangent ratios, or the three pieces that we frequently talk about. So I like to write them vertically. The sine, the cosine, and the tangent. These are the three pieces that we're going to use. The mnemonic for it is called So, Ka, Toa. And especially if you are taking geometry right now, very, very soon you're going to be expected to memorize this. It shows up a lot. So, sign is actually spelled with an E on the end. I should write it out completely. The S-I-N is the abbreviation. So, what do you think O stands for? Opposite. And the H? Hypotenuse. Cosine, we have A for adjacent. And again, H for hypotenuse. And then O and A again, we have the opposite and the adjacent. So again, these don't mean a whole lot by themselves. Sine, well, it means opposite over hypotenuse, but again, you need that point of reference. And so it's never just going to be sine equals number. Does not exist. It's the sine of something. And so, if I talk about the sine of A, it will be what?
It would be little a,
Over C.
Over C, our hypotenuse. What would be the tangent of B?
Little b.
Yep. The opposite is our little b, and our adjacent is little a. The final thing that we can do with these, and why those tables in the calculator get so important, is because not only can you do these sine or cosine, you can also do the inverse. And so if I do the sine inverse, -1 is an inverse. If we do the sine inverse of this A over C, C, not B, the calculator would spit out the angle measure of A. And again, that's why we switched into degrees. We want it to give us degrees rather than radians. And so we would want it. We don't have a whole lot of numbers right now, so we're going to do that in a second. But this is just the background, what those pieces mean. I'm going to erase this stuff. I'm going to leave our triangle as reference. And then we're going to start some real problems. So the first one says, we have this triangle, it's a right triangle, and we have side 6 over here, and they ask us what this side is. But they also tell us, I can't spell, that the sine of C equals 2 over 3. So filling in our letters, we have A, B, and C. So, ignore this for a second. just with this given information, what would the sine of C be? Here's C.
It'd be little c over.
Alright, so we are interested in C. So looking at just this triangle, which one's the hypotenuse? AC, or the question mark. This is our hypotenuse. Again, looking at C, this thing that we know, this 6, is it adjacent or opposite angle C?
Opposite.
Opposite. So, for our sine, what over what are we looking for? What's our fraction ratio? That's the one they gave us. From the picture, we know that it's 6
So it's
over
9.
question mark.
That's
So we have 6 over question mark. You catching on? 6 over 9 is equal to sine C. It's also equal to 2/3. And so the question mark would have been right here. The question is, okay,
just
6 over something equals 2/3. You can do the cross multiply. You can do, oh, in order to get from 2 to 6, I need to multiply by 3. So 3 times 3 equals 9. However you see those fractions, it's up to you. But this is the most vital part that you need in order to find that setup. So you need to be able to say, okay, sine applied to the drawing is this, but they tell me it equals this, so these two things equal each other. Did I lose anybody? Round did not erase well. All right. Second question, for an angle with the measure A in a right triangle, so we have angle, and the A is kind of a loopy A, it's a Greek alpha. But they tell us the sine of this angle equals 40 over 41, and the tangent of alpha is equal to 40 over 9. And based off this question, I'm afraid I misremembered on those Pythagorean triples. It should have been 40, 41, and 9, not 41, 42, and 9. So if you wrote that down, please fix it, and I apologize. And this is the setup. They ask you, what is the cosine of alpha? This is not going to be a calculator problem. It's just interpreting what these things mean and getting it into the form. So, we have a right triangle. I'm calling this angle alpha. So, completely ignoring the top for a second, I'm going to switch back into red. Which side am I going to ask about first? I am always going to say find the hypotenuse. The hypotenuse is the one that does not change. The hypotenuse is very, very consistent. So which one is the hypotenuse? The slanty one. And if you get lazy like me, you stop writing out the word hypotenuse. So now we need to talk about the idea of opposite and adjacent. Which one is opposite our angle? The vertical one. And then last one left, adjacent. Yes, this one's attached. Other things I meant to write over here. This is literally opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. I meant to write the fraction bar. So, let's talk about sine. Sine is literally the opposite over the hypotenuse. If sine is the opposite over the hypotenuse, what's our opposite? 40. So our opposite, I'm going to switch back to black, is 40. Over hypotenuse, what's our hypotenuse?
41.
41. You could have the Pythagorean triple, but that's not really useful on this one. The tangent is again opposite over adjacent. Our opposite is 40 again. We've already got that one. But our adjacent, what is it? 9. They ask about the cosine. Cosine is adjacent over hypotenuse. So what will our cosine equal?
9 over 41.
9 over 41. All it's testing you on is using that relationship. You aren't calculating, you aren't solving, you're just being able to match pieces with other pieces. Is somebody waiting?
I think so.
I just checked. All right, so next one, we get a word problem with it, but they give us a picture right away. I am always in favor of a picture. So they tell us that this is 20 degrees. This is 500 meters. And they drop our question mark right here. So, filling in the word problems, it says the hiking path to the top of the mountain at the steepest place makes an angle 20 degrees with the horizontal, and it maintains this constant slope for 500 meters as illustrated below. Which of the following is the closest approximation to the change in elevation in meters over this 500 meter section? And so we will be rounding to the nearest whole number. So again, anytime they throw sine, cosine, and tangent at you, which they do by giving you approximate the cosine of 20, the sine of 20, the tangent of 20, and so that's in case you're making do with a 4-function calculator, it is possible. But looking at this problem, the very first question is which one? Sine, cosine, or tangent, which describes the situation that I've got. And so here is my angle, and I have this piece of information that I'm looking for, and this piece of information that they gave me. Is this going to be a sine, cosine, or tangent problem? Is the first thing that you need to know. Sine. We don't have anything for our adjacent. We only have the opposite and the hypotenuse. And so we are going to say that the sine of 20 is equal to this thing that we're looking for over 500. First one you get to use your calculator on. When you type in your calculator, you're going to say sine button 20 and close the parentheses, and you don't need the degrees. What are you getting?
0.34.
0.34?
Yeah.
And again, they gave you the approximations. They agree with you. 0.34. Now, nothing to do with trigonometry. We're just back into solving territory. What would you do next in order to solve this problem?
Times by 500.
Times by 500. So you're going to take that 0.34 and multiply by 500.
So we're talking the same thing about our calculation.
You're still in radians. So that's the mode. You want to come down here and arrow over there and then hit enter, and that moves it. And so now try it again.
Wait, mine is just noted above.
No, you're in degrees, you're good.
Oh, I see, okay. I thought it was like a one.
No. What are we getting?
171.
All right, so they are actually rounding it to the nearest tenth, or the nearest tens place. And so I would say that 170 would be the closest one. And so since they ask you to approximate, it's perfectly fine to say, okay, that's close enough. Any questions about that one? All right. Again, we have a triangle. This one is very straightforward. They give us all three lengths. And it asks us which of the following is true about angle A. So I'm going to write angle A here and ask you a different question. I want you to write 3 true statements about angle A. Find the sine, cosine, and tangent. What are the 3 things that we know about angle A? Sine is going to equal 12 over 13. Our cosine is going to equal 5 over 13. And our tangent is going to equal opposite over adjacent, 12 over 5. So, things that I call the gut check. What is always the longest side of a triangle? Hypotenuse. Yes. So, with that, of the 3, tangent is the only one that can be bigger than 1. Because here we're always dividing by the biggest number, we're always dividing by the biggest number. Tangents can be greater than 1. Because sometimes the opposite side is longer than the adjacent side. And so that's a gut check. If you get a sine or a cosine that's bigger than 1, something went wrong. But tangent, it's okay. Along the same lines, what would be the sine of B, the cosine of B, and the tangent of B. Taking answers. What's the sine of B? 5 over 13. What's the cosine of B?
12 over 13.
Yep. And the tangent of B, just the flip, 5 over 12. So, what do you notice about these fractions or these ratios, these relationships?
There's a matched all of them.
The sine of A is the exact same as the cosine of B. They are very interchangeable. Sometimes I've had people who only solve for sine and they just default to that all the time. It's a little bit slower, but it is possible if you absolutely hate it. But again, back to a very basic triangle. We have 10, we have 6, and we have 8. The question is, I want the sine of A as a decimal. What do you get?
0.6.
0.6. It is literally 6 over 10, 6/10, 0.6. Alright, I'm going to save that one and come back to it. So we'll move on to here. Alright, we have one more that is the basic, and then it's going to start getting a little bit more complicated. Don't worry. So, one more basic one. We have 8 and 15 and 17. Oh, that's a Pythagorean triple I didn't know before now. So, they want you to ask or answer, what is the value of the tangent of A when A, B, and C? Tangent is opposite over adjacent. What is opposite our angle A?
15.
15, and our adjacent is,
8.
8.
so again, we have a tangent that is bigger than 1. With tangent, it's a 50-50 shot. Half the time it'll be greater than 1, half the time it'll be less than 1. It just depends on which side gets to be on top. All right. This is a problem that is beyond what you've been taught, even if you've done geometry, but it's not hard. So, what they have is what's called a unit circle or a circle in the coordinate plane, and we have a point down here that is at +4, -3. And the question is, this is the angle. What is the cosine? So again, beyond what a lot of you have seen or done, but we can still tackle this with what we know. What does this 4 equate to? Yeah, 4 is the horizontal distance. 4 is the x coordinate. It just means this distance right here is 4. What does the -3 equate to? How far it is down. So this is -3, or a distance of 3. Back to Pythagorean theorem, Pythagorean triples, however you see it. If this is a length of 4, and this is a length of 3, it's negative because it's down, but its length is 3. How long is this side? 5. So they're talking about the angle out here, but we can also refer to this angle in here. It's going to be kind of interchangeable. What is the cosine of this triangle?
4 over 5.
5. And so that's all the answer would be on this one. 4 over 5. It looks scary. It's got some things that you haven't dealt with yet, but you can still apply the trig stuff to it. The fact that it's a coordinate means it's a triangle. It's a triangle, you can find that length. You can find that length, you can do a trig ratio. And so, if you get to a problem like this where you really don't know, give it your best guess. It's not as scary as it looks. All right. Word problem again. It says, at a certain point, oh look, it's point. The angle of elevation formed by the level ground, okay, level ground, and the line from that point to the top of the Eiffel Tower, okay. You do not have to be a great artist. I have drawn the Eiffel Tower. Enough to give you the reference, it does not have to be gorgeous. But anyway, at a certain point, the angle of elevation formed by the level ground and the line at the top of the point of the Eiffel Tower is 70. So this angle formed by this beautiful drawing is 70 degrees. Which of the following expressions is equal to the distance in meters between that point I think I found a typo. I didn't realize that. Bad test. Occasionally it does it. But anyway, between that point and the center of the base of the tower. So center of the base, again, is just making sure we can deal with the beautiful right triangle. But all of the options have this 320 in them, and that's not mentioned in the words at all. So we're gonna have to make an assumption, which I hate. If I were taking the test, I would register a complaint. But we're going to assume that they told us we were 320 meters, because they mentioned meters, away from the base. So again, bad test, that's trouble. Want to look at it and double check if I'm not missing something, because that's driving me crazy. So, the question is, how do we find the height? The one that I'm always going to ask is this a sine, a cosine, or a tangent problem? What pieces of information do we know, and what piece are we looking for?
Tangent.
Tangent, because we neither know nor care about this hypotenuse. We don't have anything to work with it, and finding that number wouldn't help us at all. So instead, we are interested in this height, which is the opposite according to our chart, and the adjacent, which is this distance. And so the tangent of 70 is going to be equal to this thing we're looking for over 320. So again, calculators are useful, but they're going to be overrated on this problem, because in the options they give us, everything is in terms of tangent 70. There's nothing that's been calculated out. It's just something with sine, cosine, tangent. It's comparing to the 70 degrees, but it doesn't actually calculate it. And so what's going to happen is you're going to just leave this. Consider it a number, and we're just holding on to it, but we aren't typing it into the calculator, we aren't getting a decimal, we're just leaving it as the tangent. And that happens more than half the time on the test. The calculating it out is the exception, not the rule. So what do we have to do to get our variable all by itself? How do we cancel that 320? Multiply. And so we're going to bring it out here, and we had 320 times the tangent of 70. And that's our answer. We don't calculate it, we don't type it out, we just leave it alone. Interestingly enough, I'm tempted to type it into the calculator, and I don't know if this problem is correct or not. Maybe that's the real height of the Eiffel Tower, maybe they just made it up. I don't know. It's a 50-50 shot. All right, we are almost out of time, so I will show you one more in the category that I call easy hard. It's easy once I show you, it's hard until you get it, because it's going to be very intimidating. You haven't seen it before, yada yada yada. So it says the function y equals 2 sine of 8 pi x is graphed in the standard xy coordinate plane below, and it looks like this. And then right here, they tell us that this is 1. So we've got this lovely loopy looking graph. They gave us this crazy equation, and then they ask, how many x-intercepts? And the equation is from 0 to 1. scale of 1 to 10, how intimidating does this problem look? It's got this crazy equation, it's got a loopy graph that you may or may not have seen before. How scary is it? It's about a 2. The reason why is this is a pre-algebra question. It asks how many x-intercepts between 0 and 1. With these inequalities, is 0 part of our answer? No. So we're not counting this one. Is 1 part of our answer? No. We're not counting this one. How many times does it cross that line?
7.
1, 2, 3, 4, 5, 6, 7. 7 is your answer. That's how many intercepts there are in that interval. It just crosses 7 times. So again, equation you haven't seen before. Ooh, that was horrible noise. Graph that you might not have seen before, but it's just saying how many times does it cross the x-axis in that interval, especially if you know that these are the not included inequalities. All you have to do is count them. You don't have to do anything with this equation at all. So again, trig can be kind of tricky, but as long as you have those, it's pretty familiar. So I would endeavor to memorize these before testing, especially because if you are doing anything geometry onward, they show up every year. I went to a math meeting on Friday with a bunch of different math teachers, and we were talking about the curriculum and what is the overlap between the classes, and sine, cosine, and tangent shows up in everything from geometry on. It just keeps coming back. It gets used in different ways, it has those crazy graphs, but the building block is that triangle. And so the sooner you can memorize it, the better. All right. It's up to you. Do you want another easy one so you can feel confident about it, or do you want to challenge one to see what they look like? You want the two? All right. So now we have a circle. Within this circle, we have a right triangle. We are told that this is a distance of 1, this is a distance of 4, this extends out. We've got a right triangle right there. This is point A and point C. So that's our setup. So it says the angle is measured in degrees. That's good. Which of the following expressions in centimeters represents the arc length AC? They're looking for this curved length. So, a few different things going on here. First of all, if you're told this is angle 1, or this is length 1 and this is angle 4, I'm going to call this that alpha angle again. How would we find that angle? That's the first step.
Inverse sine of 1 over 4.
Yes. So 1 and 4 compared to our angle are a sine relationship. We have the opposite and the hypotenuse. So the sine of our alpha is equal to 1 over 4. If we want just the angle, we use that inverse, and the alpha is equal to the inverse sine of 1 over 4. Inverse sine. And we're going to leave that there. It does not calculate it out. It leaves it at that inverse. So that's the trig part. Our next part is, okay, what's going on here? So, circumference of a circle, distance around a circle. Do you remember how to get that? 2 pi r? Yep. Either diameter times pi or 2 pi r, both work. What do we have? This 4 is our radius. And so we know the whole thing is going to be 8 pi. How many degrees are in a circle? 360. And so if we take these degrees, whatever this angle is, we don't know, but we're going to put this angle over 360. That's what fraction of the circle we have. If this were 180, we would have half of the circle. If it were 90, we would have 1/4 of the circle. So we don't know what that angle is, we calculate it out, but it's this divided by 360 gives us that fraction of the circle. And so we're going to take this sine inverse of 1/4 divided by 360, and that's our fraction of circle, and then we're multiplying it by the circumference of circle. So we are getting the fraction of the circumference. The 8 and the 360, I believe, simplify down. What is 8 divided by 360?
Point 0222.
But as a fraction, does it? Okay. That sounds better. I'll double check what was going on there. So 360 divided by 8 is 45, so this reduces down to 1/45. And so we have sine inverse of 1/4. And traditionally pi is stuck out here at the front, so it's really obvious that it's not part of the sine. And then all of it over 45. So that is the hardest that I anticipate you seeing. It's about a 1 in 10 chance that you get a sine problem or a trigonometry problem that's that difficult. Most of them are just the find the sine, find the cosine. Given these sides, what would the inverse be? So that is the stretch. Take a break, grab a drink. Do we have a drinking fountain? And we will pause shortly.